Hello everybody. I know it's been a little while, but in today's video, I kind of want to talk about some intro to probability. And you might be like, well, why do I want to talk about this? And the purpose is because I kind of want this channel to be an introduction into sort of things, or at least that's what I've been thinking of kind of doing after taking a break for a little while. Because I feel like, well, this isn't supposed to be an in-depth channel except for like maybe some SAT stuff. Because it's supposed to be like a beginner STEM channel. So, I'm thinking like if we do intros to everything, maybe people will find what they like and explore topics on it more. Plus, I think Abiram is taking a step back from the channel. He hasn't posted anything in a while, so not really sure. But anyways, I want to talk about some basic probability stuff. So probability, right? So probability, like you flip a coin. Right? You flip a coin, let's say, what's the probability you get heads, right? Well, you say there's two sides of a coin, you flip it, it's half a chance, right? Or one half, right? 50% chance. And you know that probability or like percent is out of one, so 0.5 because half a chance. So that's like the most basic stuff. It's like there's 52 cards in a deck. What's the chance you get a diamond, ace, right? There's only one of those, so it's 1 out of 52. Like if it's a shuffle deck and you pull it, or your pull card, right? So what happens when you want to do multiple events? So let's say we have something like this. So let's say, let me set up a scenario. Okay, hold on. So let's say we have something like this. Okay, these are two different like sample spaces, which are just spaces like the events can occur. And let's say that we're doing something like this. We're taking let's say these circle things are marbles, right? So let's say these are like marbles. Now let's say that we're taking one and then two. So we're gonna draw like a random marble from this like circle space first, and then we're gonna draw a random marble from this circle space. So we're going to do this first and then this second. That's very important for the ordering. So let's say, what's the probability that from both we get blue marbles? So blue in both. Well, what you can set this equal to is the probability that you get blue in the first, and this upside down n means and, blue in the second. So how do you calculate this? You might be like wondering, right? So there's kind of two ways to calculate this. You can do the probability that you get. So like I was saying, there's two ways you can do this. You can take the probability, or we can use a probability equation. So when doing probability, there's like if you're taking AP Stats, which is what I'm taking, which is kind of why I'm making this video. They give you this. They have the probability of A, U, B. Now, what does this U mean? Well, if the N means and, the U means or. So it's like or and, right? That's just like, or. It's or. So the probability of A or B, and these are just two random events, right? A or B, equals the probability of A plus the probability of B minus the probability of A and B. Now, basically what this is saying is this is like the probability of A only plus the probability of A and B. And the reason is because A can also be A and B, right? Because you see it still includes A. So that's still part of A. Plus the probability of B only plus the probability of A and B, which same reasoning here, right? B is in this, so it's still part of the probability of getting B, minus the probability of A and B. And you might be like, well, what's that for? Well, we only want one probability of A and B. So if we subtract the probability of A and B, we only have one of those left. And so this is kind of showing like this is the probability of probability of A only, which means you wouldn't get B, plus the probability of B only, which means you wouldn't get A. That's still A or B. And then the probability of both is still A or B. But because basically what this is saying is that you have the probability of one or both, right? So it includes the and naturally, which is why we have to subtract it, because there's already two. So we subtract it, and then there's only one and. So let's use our blue for this. So we have the probability of blue or blue equals, and then our probability of blue 1 plus our probability of blue 2. And this is the probability of getting a blue in the first one, probability of getting a blue in the second one, minus the probability of blue 1 and blue 2. And this is what we are looking for, or solving for, right? So I guess let me circle this. So now you say, well, how do we find this? Because if we want this, well, we can't have two unknown terms, even if we know this. Well, first, let's find the probability of getting blue in the first one. I guess let me change the color for this. So we see that we have 2 blue and 3 red. So you might be thinking, well, 2 over 3. Well, no, because we have to add them up. So there's 5 marbles, and there's only 2 blue ones. So the chance that you draw a blue marble is 2/5. And the probability of B2, let me just erase this, if you have OCD or something. So probability of B2 is going to be, well, there's 3 blue and 1 red, so 3/4, right? You randomly draw, there's a 3/4 chance. Now, how do you find the probability of B or B? Well, remember, so we're kind of going to have to think about this, right? Well, we have the probability of like B1, right, to be, well, basically what we can do, and this is the easier explanation, is to find out every situation where you could have this. So, sorry, let me write B1, B2. So you can say that you have, let's say you take B1, and let's use these as our examples, right? Let's say you draw a blue from the first one, but then you draw a red from the second one. Well, that's still an OR, right? Now let's say you draw a red from the first one, you draw a blue from the second one. That still fits in this, right? Because you still have the B2, one of them's blue. And then you have the B1, and you draw a blue from the second one. Now, this is kind of the second method I would do, because it requires actually calculating the and first. But this is useful if you have the and. So let's just calculate the and right now, just so we can like kind of skip this method, but I'm still going to explain it, right? So the and, well, how do we do this? Well, we draw from the first one, so we know that that's 2/5, right? There's a 2/5 chance we get a blue. 2/5. And then we draw from the second one, and that's a 3/4 chance we get a blue. Now, okay, you might be like, well, why don't we like add them, right? Why do we multiply them? Well, first let me see, probability of blue 1 and blue 2. So why don't we add them? Well, let's just think about this, right? This is 0.4 and this is 0.75. If we add them, we get a probability greater than 1. Now, that's not always the case, but in this example, it works well to show why we don't just add them. Because if we added them to find the probability of like both of them happening, it would be greater than 1, and you can't have a probability greater than 1. It's out of 100. And the 1 is like the 100 in this case, so it's out of 1. So yeah, you can't have a probability above 100%. So we multiply them, and this is like if the events are in succession too. If they're not in succession, there's like different things you have to do. But because this second one like follows the first, you can do this, right? So this is going to be 6/20, which equals 0.3. So that's the answer we're looking for initially. But so how does that work in our equation above. I guess let me just keep that there. So we have our and, but how do we calculate this like sort of without it? Well, like we said, we have these three things. So how do we calculate the or? So let's say, what is the probability of blue 1 and red 2? Well, we know that that's 2/5, right? Because that's our blue 1. And then our red 2, well, that's 1/4 because there's 4 marbles and 1's red. But then we also have to add our probability because this is an or. For or you add, for and you multiply. Because this is like blue 1 and red 2, right? This is just what this is, sort of. So for R1 and B2, well, let's see. There's 3/2 or 3/5 because there's 3 red marbles in the first one, and out of 5 total. And then blue 2, well, that's 3/4. And then we have our blue 1, blue 2, which is 0.3. And then we get what is this? I think it's 0.85. Yeah. So now we can kind of use this method. And this method's really like, I don't know why I started with it first. That was kind of silly, but it's kind of like for if you're given the and you need to find the or if you're given the or and you need to find the and. But we have the or, so let's find the and. So we have 0.85 equals our probability of blue 1. We calculate to be 2/5, which I'll just change to 0.4. And then 3/4 is our blue 2, so plus 0.75. And then minus our probability of B1 and B2. So this is going to be 1.15. So we do 0.85 minus 1.15 because you subtract from both sides. This is just some algebra. Equals negative B1 and B2. So you see, this is going to be negative 0.3 equals negative probability B1 and B2. Just get rid of the negatives because they're both negative, so you make them positive. And then you get that 0.3 is really our answer. Now, kind of a longer way of doing it, right? If you just did this method first, a lot faster, and you should do it first. Like, the method I was using is for, and there are questions. There are questions if you're taking the AP test. I mean, if you're not taking the AP test, then it's like, whatever. This is kind of supposed to be an intro video anyways. But if you're taking the AP test, there's questions like that. So now I want to talk about one last thing, and that's the probability, conditional probability. So let's say that a boy and a girl are eating ice cream, right? Or they normally eat ice cream. I don't really know what this is. Ice cream, right? So let's say that we have a table here, and this is a normal way to do conditional probability questions. So let's say we have a boy, we have boys and girls, and then we have something like likes ice cream, and dislikes ice cream. So 2 separate categories. Now let's say that 10 boys like ice cream and 15 girls like ice cream. And then 5 boys dislike ice cream and 4 girls dislike ice cream. Now let's add up the totals first. So we get, well, 10 plus 5 is 15. 15 plus 4 is 19. And then here you get 10 plus 15 is 25. And then 5 plus 4 is 9. So you get 34. So now, what is conditional probability? Well, the conditional probability is kind of like saying given something. So the way that you want to write this is you say, let's say, what's the probability that if we randomly select a person, that they're a boy, right? Boy, given they like ice cream. Well, for any probability, or for any given conditional probability, So A given B, and the line means given. Like it basically means given. Like you're given this information. What's the probability of this happening? So given that this scenario happens, what's the probability of this? So you have the probability of A given B, and is the probability of A and B over the probability of B. Not the probability of A, but the probability of B. So the probability of whatever is behind or already given, right? So behind this bar. So now let's use this in our example. So the probability of boy and likes ice cream. I'll say likes ice because a lot of writing is, well, there's 10 boys who like ice cream. So that's going to be 10. And then over our total of 34, because there's 34 people in our sample. And the probability that a person likes ice cream, which is after the given, so that's what's going to be on the denominator. I'll say likes ice again, equals, well, what do we have? Likes ice cream, we have 25 over 34. So using this, we get that our probability of boy given check mark, I'll say that for likes ice cream, is going to be our and, which is this one, 10 over 34, over our likes ice cream, which is 25 over 34. And these 34s are basically going to cross out, and then you get 10 over 25, which equals 2 over 5. So 0.4. And you might be like, well, Kenny, that doesn't seem very hard. And no, it really doesn't. But there's an even easier way to do it. So think of it like this. Instead of doing all that work, think of it like you're taking, well, you have the probability of A given B. Well, think of it as like A over B total B, right? And so it's kind of like you're rotating this, like you're doing the probability of A given B, right? And then, so it's A over B, but it's over the total B. So what we have is the probability of our boy, right? And this is in the sample space of B, right? It's in the sample space of B. So what I want to say is that we have our A in B. And we see, well, the probability that it's a boy, or how many boys are there, is our A, right? Well, there's 15 boys. But if we're looking only in event B, which is that they like ice cream, there's only 10 boys. So we're saying 10, right? A in B are boys, how many boys like the ice cream? And then we're saying, well, total B. Well, our B is likes ice cream. So how many people like ice cream? 25. And then you see that this is also 0.4. And this really only works if you're given a table. If you're given a word question or something, it doesn't really work. But that was basically conditional probability, and I didn't want to really go too in depth into it, but that's kind of what I wanted to cover. So anyways, thank you guys for watching. I hope this helped in some way, and have a good day.